and doing translations. We did them on the coordinate grid, and we did them with constructions. Now we're going to construct reflections. So we're going to see how could we draw a triangle and flip it to the other side of a line of reflection. Skipping through some of this. So big idea is that a reflection is when we take a point and we go to the other side the same distance away from the line of reflection. So let's say A to this point was 5 inches. Then A prime to this point was also 5 inches. So it's got to be the same distance away from that line of reflection. The other big idea is that the line of reflection is perpendicular, right, to where there won't be a segment there, but if there was a segment there, it's perpendicular to that point A to A prime is perpendicular to our line of reflection. So like if it was straight up and down, it's kind of easy. It's like, oh yeah, it would just flip to this side and it's the same distance away because it's perpendicular and the same distance away. And remember, this is called a perpendicular bisector. So we tried to figure out how we could do it in class just by practicing, try to make it the triangle over here. But let's go to the notes to see like the actual way to do it. So to reflect or flip a point or a figure over a line, the image is always the same distance away from the line as the pre-image. So B to line T would be the exact same distance as B prime to line T. So we could say they're congruent. So remember, that's called a perpendicular bisector because these lines are also perpendicular or create 90-degree angles. So that's how we know if we're reflecting. We're just flipping it. You could think of like if it was on a piece of paper, if I folded it on line T, it would go to the other side when we fold it. Now how we construct it is we need a perpendicular line through B. In Desmos, there's an easy way to do this. If you hit construct more tools, you can do a perpendicular line. So we want to be perpendicular to this line. Oh, must hit the wrong button. There we go. So we need to be perpendicular to this line, and we want to hit point B. Now that was the first step, so we know point B prime's got to be somewhere over here, but we don't want to guess. We want it to be the exact same distance. Well, if I made a circle from the middle to B, well, the center to the circle is the radius. The center to the circle is the radius, just the other side. So it's the same distance to the other side. So this is B prime. So I'm going to label it B prime. So capital B, and then right next to your enter button is like the quote symbol. If you just hit that, the first one comes up. So there we go. So then we want to do the same for A and for C. So I'm going to make a perpendicular line. I want to be perpendicular to this. I want to be through A. And then I want to be the same distance to the other side. So to measure distances, we use circles. So I want to be from the center to the edge to the other side. There's point A. So we'll call that A prime. And then last one, point C, same thing. If you were ever like getting confused by the circles, you could also click the circle and hit hide, and it goes away. And then you could unhide, just in case like it's getting confusing, because we're not using these two anymore. We're just gonna make C. So I need to do a perpendicular line through C because I want to be perpendicular and to the other side. I also got to make sure it's the same distance. So here's the middle to C, middle, it would be right there. C prime. Then the last step, right? It's a triangle, so let's just connect it and make it look like a triangle and make sure it looks like a reflection. Let's see if it looks like it flipped. So looking at this triangle, it looks like it flipped or is a mirror image over that line. We use perpendicular bisectors, or a perpendicular line, and then the same distance to the other side. So we could do that with as many points as we need. So the cool down, give it a try. We want to flip A, B, and C to the other side. Now point B is on the line. So what do you think is going to happen if it's on the line? Just one little trick.